data visualization and analysis. So you've already done your pre-planning and the experimental design, and students are either collecting their data currently or they've just finished their data collection before they move on to data visualization. So again, we're designing the experiment so the students can make valid and objective conclusions at the very end. So we've already asked the right questions. We're already collecting the right data or on the path to collecting the right data. And now we need to analyze the data correctly in order to make those valid and objective conclusions. So we want to be able to use data to support our conclusions. So we're going to build upon all of the phases that we've already done and utilize data visualizations and statistical methods to support the conclusion the student wants to make. So in this phase, the students will identify what's good and bad about graphics and data visualizations. They'll learn how to appropriately visualize data through a number of activities. They'll also recognize the need for statistics in this role of statistics activity, which is actually the topic of the next video. And they'll be able to identify and select the appropriate statistical test and ultimately evaluate their conclusion. So we've already done the planning process. So we've have all of these materials leading up to the analysis and conclusion. So all of the activities that are provided for you on the workshop website all go through and support the analysis and conclusion. So data visualization is your very first step in data analysis. It should support the conclusion of your research question. That's why data visualization is so important, is that visual to support your conclusions. So the next activities will help build a student's intuition about what makes a good and a bad visualization. What are the key aspects of a visualization that they should look for in making their own? Like labeling appropriately, the use of color, what types of graphics are best for certain types of data. We want them to explore a bunch of different options so they know what's out there and we're not limited to pie charts and bar graphs. We'll also help them develop appropriate graphics and learn to see what they would be best for their data. So for example, one of the data visualization activities asks the students to rank from novice to emerging to exemplar of all these different aspects of a graph that make it a good data visualization. Because the better foundation of good versus bad data visualization will really help the students create their own. So the next activity that really helps support their thinking in their own data now, before they're looking at other people's graphics, well-designed commercial graphics, commercial plots. There's lots of different options out there to look at different plots and provide different opportunities to have your students look at different contexts. But the final one brings them back to their data. So we're going to ask them to draw their own hypothesis. So what does that mean? That means you want them to think about the data that they're collecting and what it's going to look like. So this is while they're doing their experiment. There's usually a lull in your class where they're collecting their data and they haven't really gotten to the point where they're going to actually analyze the data because the data collection isn't over. But they've started collecting their data, so they know the types of data that are coming in. And so you want to ask them to draw their hypothesis. What is your data going to look like if you can show differences between the group? What is your data going to look like if you cannot show differences between the groups? So you want them to anticipate the data that they're going to collect, and you want them to anticipate the types of graphs that might be appropriate. Because if you're looking at whether something is present or something is not present, that graph is going to look very, very different than if you're comparing two means that are numbers, right, that are numeric in nature. So we want to make sure that they're choosing the appropriate plot for the type of data. So this draw your hypothesis activity allows them to internalize and use their own data in creating these fake graphs. They're not going to actually plot the graphs for real. They're going to just sketch them. What are they going to look like in theory? So there are a lot of tools for data visualization out there, and I'm going to present just one of them. One of them is from an Art of Stat website. It's actually through a textbook, but they're free apps that are run on R Shiny. So R is very intimidating to create any graphics as a science student, or as really, even as a statistics student. They're very intimidating, and programming in R or some other software is oftentimes very daunting. So there are a lot of apps out there that create visuals very easily for the students. For example, this is just one of many tools that we provide you as a resource. So this one is about exploratory data analysis that will allow them to quickly visualize their data, whether their data is categorical, whether their data is quantitative, or whether their data is over time. They can select the type of data that they're looking at, and it will help you out with a number of different graphs. Like, for example, the Explore quantitative data will do side-by-side histograms. They'll do side-by-side box plots. They'll do side-by-side density plots. There's lots of different choices within the app for your students to use. They have built-in examples within the app, and also there's also the way to cut and paste your students' data into the app very readily. It prompts you to enter data, and all you have to do is cut and paste, and it's there, and the students can create plots in R, but in a very user-friendly way.